The solution is comprised of three components: controller, client, and gateway. The controller is the policy decision point, or essentially the brains of the system acting as a trust broker. The controller checks context and grants entitlements. The gateway is the policy enforcement point, and they are located wherever resources need to be protected. The first thing to note is that the controller and the gateway are completely cloaked from prying eyes using a technology called Single Packet Authorization, or SPA for short. With no exposed ports, this protects the system from many types of network and credential-based attacks. Basically, you can't attack what you can't see. When a user needs to access a resource, the client connects to the controller using SPA. The controller then authenticates the user with an identity provider, which can use SAML, LDAP, or Radius, to validate and authenticate the user and pull back all configured user claims to use in determining access entitlements. The controller then checks user context, performs a deep device posture check, and pulls in data from any third-party sources like an ITSM, a SIM, or other security tools. Based on this multi-dimensional identity profile, the controller generates what we call a live entitlement token and sends it to the client via a signed certificate. It is a live entitlement because it is dynamic based on context and risk at the time of access and therefore not static. Again, using SPA, the client sends that live entitlement packet to the gateway. The client can only connect to gateways where that user has been granted entitlements. Once the gateway validates that the signed token has not been tampered with, it dynamically generates a segment of one that allows access to specific resources that have been granted. In our example, this user only has access to application 1 and the other resources remain cloaked. Finally, Appgate SDP continuously monitors the system for changes in context and can adjust or revoke access privileges in near real time. It adjusts the segment of one based on this change in context. For example, if the user's role changes, they will lose access to one application and gain access to another. This is a simplified example of how Appgate SDP works.